Okay, this is going to be the second part to the imaginary, so we're going to be talking about complex conjugates. Whenever I say conjugate, that's going to include a plus or minus. So it has the form of a plus bi and a minus bi. The sum and product of two complex conjugates are always real numbers. Okay, so if I multiplied them, they would become a real number. So it's similar to square roots where they have the positive side and the negative side. So if I have a 2 minus 3i, I also have a 2 plus 3i. If I have a negative 5 plus 2i, I also have a negative 5 minus 2i. You always flip the thing that's attached to the imaginary, so when we go to multiply them, my i's will disappear. Okay, it's the conjugate of it. So my first one here, we cannot have imaginaries in the bottom, so to get rid of it, you multiply by its conjugate. The conjugate of negative 5i is a positive 5i, but what you do to the top, or what you do to the bottom, you also have to do to the top. Okay, so we're going to have to distribute it in, so it's multiplied to the entire top. So 3 times 5i gets me 15i. And then negative 8 times 5 is negative 40. And then I times I is I squared. And then my bottom, negative 5 times 5 is negative 25. I times I is I squared. So my I squareds, I'm going to change them all to negative 1s. So now my i's are gone in the bottom, which was what I wanted. And then I just simplify. So 15i, two negatives will make this a positive 40. And then this will be a positive 25. And then we simplify if we can. It looks like they're all divisible by 5. So if I divide everything by 5, I got 3i plus 8 over 5. So there's my simplified answer. Okay, my next one here, multiply by the conjugate. So the only one we need to flip is the I to get rid of it. So I'm going to multiply by negative 2 minus 3i to my top and bottom this time. So we distribute him in, so I get a negative 18i minus 27i squared. And on my bottom, I now have to FOIL because I have two binomials, either FOIL, distribute, or box. Okay, so my first, negative 2 times negative 3 is a 6. Outside, negative 2 times negative 3 is a 6, and we still have the I in there. My inside is 3 times negative 3 with just one I, and then my last negative 3 times 3 is a negative 9. I times I is I squared. Oops, that was supposed to be a negative 2 in the bottom. Ooh, buddy, let me go back. This little guy was supposed to be a negative 2. Somehow he changed. All right, let's refoil that. So negative 2 times negative 2 is 4. My outside is a plus 6i because negative 2 times negative 3. My inside is a minus 6i. And my last is a minus 9i squared. The reason I knew I messed up is because these need to cancel to get rid of the imaginaries in the bottom. Okay, positive 6i, negative 6i, they cancel. All my I squareds will change to negative 1s. So that's why I knew I messed up, because now all my i's in the bottom are gone. So now I got negative 18i plus 27, and then 4 plus 9, which will get me 13. Okay, neither of those are divisible by 13, so that's going to be my final answer. All right, my next one here, we only flip this one, so it's going to be 6 plus 5i and 6 plus 5i. So we're doing a double FOIL because I got two binomials. Okay, let me change colors here. Negative 3 times 6 is negative 18. My outside is negative 15i. My inside is negative 24i. My last is negative 20i squared. Now we're going to do the bottom. 6 times 6 is 36. My outside is positive 30i. My inside is negative 30i, so they'll cancel. And my last is negative 25i squared. Okay, so this center cancels. I can combine my like terms up here, so I got negative 18 minus 39i, and change my I squared to negative 1, so negative 20 times negative 1. My bottom, I canceled, and then I can change that I squared to negative 1. So negative 18 minus 39i plus 20 now, over 36 plus 25. So then it is 2 minus 39i all over 61. And none of them are divisible by 2, which is that smallest number. Okay, the conjugate of positive 9i is a negative 9i. So we're just going to distribute him on the top. So my first distribute, I get negative 27i. My second, I get minus 36i squared. My bottom, 9 times negative 9 is negative 81, I squared. All of my I squareds will change to negative 1s. And then we can change those all to plus signs. Okay, and then if I simplify that, we could get negative 3i, so they're all divisible by 9, plus 4 over 9. My next one, we're going to have a double FOIL, so we multiply the top and bottom by negative 3 plus 10i, negative 3 plus 10i. So I get 6. My outside, I get negative 20i. My inside, I get negative 21i. My last, I get 70i squared. My bottom here, I get 9. My outside, I get negative 30i. My inside, I get positive 30i. And my last, I get negative 100i squared. These cancel. We can combine my regular i's and change my I squareds to negative 1. So 6 minus 41i minus 70, because it'll change to a negative 1 times a positive 70. My bottom will be 9 plus 100 once I change that I squared. So I get negative 64 minus 41i all over 109. My next one, we got to multiply by 4i. Come on. So we just got to distribute him on the top. Negative 4i minus 12i squared. Negative 16i squared. I squareds change to negative 1, so he'll become a plus 12 and a positive 16. And they are all divisible by 4. So I got a negative I plus 3 over 4. Okay, and you could have these flip-flopped on the top. That's fine. It means the same thing. So you could have 3 minus I over 4. Okay, does the graph cross the x-axis? So should the equation have any real solutions? Using the quadratic formula, find them. So let's go ahead and find our vertex equation here. So x equals negative b over 2a. So x equals negative 4, and for negative b, it's 4 over 2 times my a. So 4 over 2 is 2. Plug it in to find my y. So I take them all out. And my y is 1. So it is at 2, 1. Right one up 1. Right one up 1, 2, 3. Left one up 1. Left one up 1, 2, 3. Okay, so should the equation have any real solutions? No, because it doesn't cross my x-axis. No, because it doesn't cross x-axis. So let's find what I actually get. So my a is 1, my b is negative 4, and my c is 5. So I got x equals negative b is going to be a positive 4. Square root of negative b squared minus 4 times a times c all over 2 times a. So I'm going to get x equals 4 plus or minus the square root of negative 4 over 2. Okay, remember we can pull that negative out with an imaginary. So 4 plus or minus I square root 4 over 2. And now we can take that square root. So x equals 4 plus or minus, it becomes 2. And then both of these are divisible by that 2. So I got x equals 2 plus or minus I as my two answers. So I've got 2 plus I and 2 minus I. So it's actually crossing an imaginary axis. So you do have two solutions. They're just not real answers. They're imaginaries. Okay, when a graph crosses the x-axis, the x-intercepts are referred to the real roots in the equation that results when y equals 0. So you solve them by doing y equals 0. You have the solutions to the equations can be real or complex. So it follows the roots can be real or complex. So my first one here is going to be starting at -3, -4. There's no stretch in here. So -3, 1, 2, 3, 4. So I go right one up 1, right one up 1, 2, 3. Left one up 1, left one up 1, 2, 3. Okay, so he has two real answers. And they are at -1 and -5. Wait, 1, 2, 3, 4. Yeah, -5. Okay, my next one is at -3, 0. There's no stretching, so -1, 2, 3, 0. So right one up 1, right one up 1, 2, 3. Left one up 1, left one up 3. Okay, so he only has one solution, and it's -3. And that's only one real solution. So there's actually an imaginary that will be happening in this one. Because that 2 tells me that there should be two answers. One of them is just imaginary. Okay, so graph this one. So this one starts at -3, 4. No stretching or compressing. So -3, 1, 2, 3, 4. Right one up 1, right one up 1, 2, 3. Left one up 1, left one up 1, 2, 3. Okay, so I don't have any real answers. So can you find the roots by looking at the graph? No, because they aren't real. Solve 25 algebraically. So that means we set it equal to 0 and we solve it. So 0 equals x plus 3 squared plus 4. So I'm going to subtract 4. Opposite of squaring is square rooting. So I got square root of -4 equals x plus 3. To get rid of it, we have to do the I. And then the square root of 4 is 2. Okay, do not forget your plus or minus. So plus or minus 2i equals x plus 3. And then all we have to do is subtract the 3. So I got -3 plus or minus 2i. Okay, sketch the possible solutions to a quadratic, so an x squared graph. For each, state the number of types of roots. So two real ones will cross your x-axis twice. Okay, one real and one imaginary should cross it once. Okay, and then no real but two imaginary won't touch your x-axis. So no real, this one will have two imaginaries.